Hello everybody, welcome to part 2 of the single area OSPF version 2 lab. So I apologize, my iPad actually crashed during this part in the previous video, so hence why I'm recording the part 2 to this. So let's carry on with task 2.5. On router 3, issue the commands in interface configuration mode to configure the remaining active interfaces to participate in OSPF process 300 area 0, process ID 300 area 0. Why no neighbor relationships formed after these interfaces are configured. So I know that's quite wordy, but we are going to enter the commands in the interface configuration mode to configure all the other interfaces in router 3 with process ID 300 area 0. It's not complicated, it's a similar process what we did just before, but we're doing it for the rest of the interfaces. But then as the second part to the question, why are no neighbor relationships formed after these interfaces are configured? Well, we'll look at that. So first let's go into the configuration of all the other interfaces. So look, we've got 4 interfaces here. Fast Ethernet 00 has already been configured, so we need to do the same now for Fast Ethernet 1/0, 2/0 and loopback 0. So specify the process ID 300 interface Fast Ethernet 1/0. There we go. So that's us entering the interface configuration mode now. IP OSPF 300 process ID area 0. So that is going to be that's all what we need to do here for Fast Ethernet 1/0. And now it's just the same process with Fast Ethernet 2/0 and loopback 0. So this is the interface subcommand way of doing it. You've got the you've got the network command way of doing it, but this way is easier because you don't use a wildcard mask now. So yes, same process here. We're just changing the interface that we're configuring. And now finally for loopback 0. So then that will be 3 interfaces that all configured into OSPF 300 and area 0, and actually 4 when you include Fast Ethernet 0/0 that we did before. So there we go now. So that's all done for those 3 interfaces. Okay. So now the reason why OSPF neighbor relationships haven't formed, again, very simple. Okay, is because there is OSPF interfaces haven't been configured on router 4 or router 5 yet. So speaking of router 4 and 5, on router 4, let's issue the commands to configure each active interface on the router to participate in OSPF process 400 area 0, and with which routers does router 4 form adjacencies. We'll have a look at that. So let's go into router 4 now, and here we can see the interfaces we have. Okay, we've got 5 interfaces now, 5 active interfaces. Whoops, sorry. Let's go back to the lab. So I guess get show IP interface brief back on the screen, and then we can see 1, 2, 3, 4, 5 interfaces. Okay, there's 5 interfaces there. And what we need to do is configure for all 5. What we need to do is configure process ID 400. Process ID 400. So conf t, and now router OSPF 400 interface serial 2/0. Okay, that's the first interface we have in our IP interface brief. IP OSPF 400 area 0. Exit. Okay, come out of this interface configuration mode. Let's go back into global configuration mode. Interface Fast Ethernet 0 starts 0. IP OSPF 400 area 0. Exit interface fast Ethernet 1/0. Oops, sorry, typo. Right, fast Ethernet 1/0. IP OSPF 400 area 0. Okay, great. So now let's do it again for the final two interfaces in show IP interface brief. And here we can see neighbor relationship 3333 so neighbor 3333 router 3 on fast Ethernet 00 loading to full state. So state has changed regarding our neighbor relationship with router 3 on fast Ethernet 00, and we've gone to full neighbor relationship there, so that's good news. Fast Ethernet is the 3/0 IP OSPF. You guys can guess the rest. 400 area 0. And finally, loopback 0. So again, interface loopback 0. Now IP OSPF 400 area 0. So IP OSPF process ID area, and then insert the area ID. That's the interface subcommand way of doing it. Okay, so there we have it now. That's configured on all those interfaces on router 4. Brilliant. Perfect. Let's move on now. So router 4 forms adjacencies with router 2 and router 3. Okay, so here we can see 3333 on fast Ethernet 0 from loading to full, but also 2222, which you didn't see previously, but that also happens there. So so that was also supposed to happen. There's a little issue with my lab, but that is what's also supposed to happen. So 2222 also forms on serial 2/0 from loading to full. Okay, so this is a bit more of an in-depth answer, but as you can see here, as you configure the interface, you should see those process 400 and router 4 form neighbor relationships with router 2 on its serial 2/0 interface, and router 3333 on its fast Ethernet 0/0 interface. Of these relationships, only the one with router 3 will elect a DR and a BDR. This is because the relationship with router 3 and router 2 formed over a non-broadcast multi-access network. Okay, so that's not a broadcast network. So there is no DR or BDR there. Now, task 2.7 on router 4 shows the commands to display the OSPF neighbor relationships that have been established on the router. Which router has been elected as the DR and the BDR for each adjacency Y. So here we go. Show IP OSPF neighbor. We can see 22223333. Okay, there's two relationships there. Here, this is full. Okay, this is full // full / dash there, so no DR, no BDR, full / DR. Okay, so here, NBMA network. Okay, right, NBMA network there. Okay, so like it said here, only the relationship with router 3, will have a DR and a BDR. Okay, because the relationship between, sorry, I think this is wrong here in the actual answer. Router 4 and router 2 formed over an NBMA network. So I think that's an issue. That's an issue in human error there when this lab was created. Those lab notes. So that's router 4 and router 2. Apologies there. Router 4 and router 2 formed over an NBMA network. So there we were. Okay, serial interface. There's no DR, no BDR. Okay, but here we do have a designated router. So on router 4, okay, here we can see a bit more explanation. Based on the output, you determine that router 3 has been selected as the DR for the relationship between router 4 and router 3. However, your output might be different depending on timing you can force a new DO and BDO election by issuing the clear IPS OSPF process command from privilege exec mode on router 3.4. Remember, I mentioned about that earlier, because if you have multiple adjacencies and you configure a router ID, well, that router ID won't take effect until you do clear IP OSPF process, because you have to transition those neighbor those neighbors need to be going to those neighbor relationships need to go to downstate in order to rebuild with the new router ID. That can't happen until you do this. Now, task 2.8 on router 5, issue the commands to configure each active interface to participate in OSPF process 500 and area 0. How many adjacencies are formed? Why? Okay, so similar process again, very, very similar what we're doing now. Router 5. Okay, router 5, and let's go into global configuration mode, interface, fast Ethernet 0/0. Okay, first interface there. Now, it should be very easy now, since we've done this now. This is the fifth, the fourth router we're doing on, because router 1 we configured using the network command way. But yeah, the fourth, we've done router 2, 3, 4, and now 5. Now we're using the network subcommand way of configuring the process ID in the area of the interfaces. So there we go. This should now be sticking in our heads. Same process again. Fast Ethernet 1/0, IPSPF 500 area 0. I've used the up command. It makes it so much more easier. So let's do it finally for loop back 0. Loop back 0. Okay. Interface loop back 0. IP OSPF 500 area 0. There we go. Exit. Perfect. Okay. Great. Show IPSPF neighbor. Okay, we can see one adjacency there with router 4. There we go. Router 4, full DR state. Okay. So that's one adjacency that we can see has been formed very clearly. Full DR state. Perfect. So that's done now for router 5. Let's move on. Let's move on in our lesson. On router 5, issue the commands to display OSPF neighbor information, which route has been elected as the DRY. So if we do IP OSPF neighbor, we see that clearly router. Here we can see the relationship full DR. Okay, so with the router 4 there. So router 1, issue the commands to display the routing table. What OSPF paths now exist in the routing table? So remember in task 1 when we displayed the routing table, and I showed you that the OSPF code and how there were no routes with that code, meaning no OSPF routes in the table. Well, let's have a look at the table now, shall we, and see what's happened. Okay. So, ooh, look at this. Show up your route. Wow. Look at all these OSPF routes now. You can see all these OSPF routes. Oh means OSPF. So we can see many OSPF routes now. Okay, and that's excellent. That's excellent. We see many OSPF routes now. You see clearly there's been a big change now. Big change. The table has more than doubled in its size because all these routes have been exchanged, and router 1's been learning routes. So that's beautiful. We've got plenty of routes now. But look at the process that had to happen. We had to configure the process IDs and also configure those interfaces into area 0. And then we saw this magic happen. We saw the OSPF routes. We saw neighbor relationships happening. we saw the neighbor relationships being created, neighbor relationships happen, and then routes start exchanging. And here now we've got a beautiful routing table. So it's like it's a bit like we've got this big family of routes now, but that didn't happen until interfaces were configured into area 0, until they were configured with the process IDs. And once the IDs were configured, the process IDs, the router IDs, and we configured the interfaces into area 0, neighbor relationships started happening, and now we've got all these routes. So this is a bit like, you can think of it, it's very, very basic analogy, but you can think about people. When people if you look at people and their phone contacts, as people start to meet more people, for example, you've got John and let's say you've got John and Stephanie, for example. John and Stephanie let's say are married, but they don't know many people. They moved to a new neighborhood. Let's say they moved to a new neighborhood in Canada, for example. Let's say they moved to Calgary in Alberta, and they don't know anyone. But as they start to meet neighbors, they make relationships, and once they make relationships, their phone contacts build up with new contacts in the Alberta area. But it doesn't happen without them building those relationships, and they need to. So obviously they need to, but first they need to have a house, they need to have an address, they need to have, they need to have a place to live, and then they can start engaging with their community and meeting people. And look, so a bit of a far-fetched analogy, but it's a bit similar to what's happening here with OSPF. We're having our routers being configured, the process IDs, router IDs, the interfaces are being configured into area 0. They've been configured into an area. Now those interfaces belong to an area. They can now they're communicating with all the routers. They're building the relationships are built, and then the IP routing table builds. So there's things that have to happen in a chain of events here for that routing table to build up. So router 1's routing table now contains paths to every other network in the topology that is configured to participate in OSPF area 0. Now task 2.11. Now remember, this is similar to what we did in task 1. Task from router 1 is in fact it's not similar. It's the exact same thing. Router 1 is going to ping router 5's loopback 0 interface 172.16.1.5. What's going to happen now? Okay, the ping should succeed. So let's have a look. Okay, so ping, whoops, let's close that. Ping 172.16.1.5. Okay, and brilliant. Pings were successful. Brilliant. I did that again, and yes, pings were successful. So pings are working now. Why? Well, it's very simple, because it's able to route 1 has a way of reaching router 5 now. It's got it can route packets to it because it's built up as routing table. So it has a path to router 5's loopback 0 interface. In addition, router 5 now has OSPF paths back to every network that is configured on router 1. So that is now task 2 all done. So thank you so much for watching this video. I hope you've learned something. I hope it's been beneficial for you. And if it has been, please like, share, and subscribe. I really appreciate it. Thank you so much for watching.